Good day, doctor and everyone. Today I will present on the topic of comparison of gas chromatography detectors and its application in food analysis. GC is an important analytical technique used for separating and analyzing compounds that can be vaporized. As the heat of GC is a detector, which provides an electronic signal recorded in the chromatogram, showing the concentration of different compounds. Let's divide into the types of the detectors. There are four usual types of detector. First one is the flame ionization detector. It is widely used in organic analysis. The second one is the electron capture detector. It is mainly used for analyzing compounds containing elements such as halogens. The third one is the thermal conductivity detector. It is suitable for detecting gases and volatiles. The fourth one is the mass spectrometer detector. It provides rich structural information capable of identifying and characterizing unknown compounds. The first one is FID, and the principle is ionization of organic compounds in a hydrogen flame, producing ions that are detected by electrodes. It has a high sensitivity, wide linear range, but it is destructive and requires a hydrogen gas supply. The next one is ECD. The principle is detecting compounds that capture electrons, generating a measurable correct. It is highly sensitive to halogenated compounds, peptides, and other electrophoretic analytes, but it is selective and requires a residue-active source. The next one is the TCD. The principle is measuring changes in thermal conductivity of gas stream as the analysis pass through. It is non-destructive, simple, and universal, but it has lower sensitivity compared to other detectors. The last one is MSD. The process is following. Firstly, gas chromatography sprays different compounds, and then analytes are ionized and separated based on their mass to charge ratio. Then finally, detectors ions of different mass to charge ratios and performs quantitative and qualitative analysis based on their advance. And it has high sensitivity and capability for identification, but it is expensive and requires high vacuum system. Each detector have unique strengths and limitations. The highest sensitivity is MSD, followed by ECD, FID, TCD, and the most selective is ECD, and then the specific is MSD, and followed FID, and the TCD is the universal. ECD and TCD are non-destructive, while FID and MSD are destructive. MSD is most expensive, followed by ECD, FID, and TCD. Each detector has a different sensitivity, and it is related to the carrier gas used. For example, TCD is one of less sensitive detector, but helium can be used as a carrier gas to make it more sensitive. Different analytes may also affect the detector sensitivity. This means the detector sensitivity is not constant. GC plays an important role in ensuring food safety and quality through many applications. The first is pesticide residues. Detecting pesticide residues in food is important for ensure food safety. And the second is food additives. Analyzing the types and contents of additives such as colors and preservatives to control food quality. The third one is identifying and analyzing flavor substance in food to study and enhance food flavor profiles. The fourth one is nutrient content, detecting nutrients such as fatty acid and vitamins. Finally, overall assignment of food safety and quality, protecting customer rights. Let's talk about the specific application. TCD is a general-purpose detector that can detect both organic and inorganic substances in food analysis. TCT, coupled with HSGC, is used for the determination of water in honey. Next, FID is considered to be a versatile detector. However, FID have high sensitivity for carbon-containing compounds and lower for carbon-free compounds. And FID can detect fatty acid in color stream. The third one, the ECD, is use hydrogen as a carrier gas and can be used to analyze pesticides and residues in fruits and vegetables with high moisture. To detect volatile compounds in beer and so on. The first one is MSD can be used to analyze fatty acid volatile compounds and can also be used to detect spoilage, contaminants, adulteration, and microplastic analysis in food industry and environment. This is a research about the determination of volatile compounds in virgin olive oil, GC, FIDVS, GCMS. This research shows a comparison between these two GC methods in determined 26 volatiles have been carried out in terms of analytical quality parameters. It includes repeatability, intermediate precision, calibration curves, limitation of detection, and quantification, linear working ranges, selectivity and sensitivity. The table shows that value of resistability of GCFID are good enough. For 26 volatiles, there only showed 10 volatiles, and only one compound showed RSD percent value slightly higher than 15%. From repeatability, GCFID is better than GCMS. So in conclusion, for the detector selection, different detectors have unique strengths and limitations that makes them suitable for specific types of analysis in food science. When selecting a detector, make sure that the detector used can detect the analyte. In the future application, develop smaller and more portable gas chromatography detectors to promote repeat on-site detection. Combined with artificial intelligence technology, automatic analysis and data processing can be achieved to improve analysis efficiency and accuracy. Here is the reference. Thank you for your listening.